Hi everybody, welcome to this section 1.2 video. And in our second video for this class, we're going to be talking about initial value problems. Okay, so maybe something you've seen before in Calculus 2. If not, that's what we're going over with today. But let's go ahead and get started on our learning objectives. So the first learning objective is going to be introduce the idea of an initial value problem and the idea of initial conditions, and we're going to solve first and second order IVPs. Okay, so what is an initial value problem? So sometimes we find a solution to a differential equation with specific initial conditions. When we solve a differential equation that has these initial conditions, we say that we solved an initial value problem. Okay, so when you're given a differential equation, you want to solve it, and you have specific conditions that you need to find, mainly just a coordinate point. So best thing to do is look at an example. So example, we have a first question here. This is a first order IVP, initial value problem. We have y prime equals y, and we have the initial condition y of 0 equals 3, and that's like a xy coordinate point. Okay, so it's like saying we have the point 0, 3. Okay, so we want to figure out the solution to this IVP. So this y prime equals y, it's a bit familiar to what we were just working on in the previous section. Okay, so if you look at example 3 in section 1.1, okay, example 3 in section 1.1, numbers B and C. Okay, so what we know from those is that I can go back to them. Questions B and C is that something like y equals c e to the x is a solution. Okay, so a solution to y prime equals 4y. So we can use this previously found idea and use it to our advantage in our problem here. So we have y prime equals y. So that means I claim that y equals c e to the x is a solution. Okay. So pretty soon in the upcoming weeks, we'll learn how to actually find a solution to this. You might have some ideas already, like separation of variables. Uh, but here we're just going to use our previous knowledge and claim that this is a general solution to a differential like y prime equals y. Okay, so I claim that's a solution. So let's go ahead and figure out what C is. We have an initial condition. So here I'll say like use our initial condition. Y of 0 equals 3. So I'm going to plug in 0 for x and plug in 3 for y. So this would be 3 equals C e to the 0. E to the 0 is just 1. So C equals 3. So the solution to the initial value problem is y equals 3 e to the x. Maybe I'll just say example 3b. Okay, so that's our solution. And there's a nice way to check if this is all true. So let me kind of check this off to the side. So check. You want to check two things. Check the differential equation part, and then you want to check the initial condition part. So here's A. Use a different color. Feels black. Here's A. You want to check the differential equation part. So you know y. We found y to be uh 3e to the x. So the derivative is 3e to the x. And so if we plug those into the differential equation, okay, so if we plug these into differential equation, what do we get? We get the same exact thing on both sides. So check. And so for part B, you want to check the initial condition part. That's just us plugging in the initial condition into our solution. So y equals 3e to the x. I'm going to plug in 0 and 3 again. 3 equals 3e to the 0, which is just 3 equals 3, and check. Okay, so just to recap, from our previous work, we found that y equals c e to the x is just a solution to this general differential equation. Okay, so that's just what we're claiming. And if you could just trust me on that. Like I said before, later on we're going to learn various methods to solving one, but right now we're just using this previous knowledge. Okay, so let's go ahead and try out example two. So, or this next example. So what I want you to do is pause the video, and it's very similar to the previous example, but go ahead and try out this one. Okay, welcome back. Hopefully you gave this one a shot, but it's pretty similar to what we were working with on the previous example. So I'm going to claim that same thing. Y equals c e to the x is a solution. Okay, trust me on that from our previous work. So we're going to do the same thing. We're going to plug in our initial condition. Use initial condition. What is it? Y of 1 equals 4. So I'm going to plug in 4 into y, c e to the 1. Okay, so not as clean as a previous example, but it's not too bad. We just have 4 equals c times e. I want to isolate c, so this would be 4 over e. Okay, so we put this back into our solution. This would be y equals 4 over e to the x is a solution to the initial value problem. But we could clean this up a bit. This is a little too ugly for me. One thing we can do, kind of go over here, is we could bring up this e, so it could be e to the negative 1, e to the x. And if you have the same base multiplying, you can add their powers. So this could become y equals 4 e to the x minus 1. And I like that a lot better than our previous answer. So here I'll say like clean up. Okay, and you could check if you want, but I'll leave that up to you, but it is correct. But feel free to check on your own if you want that practice. But okay, so that takes care of the first order initial value problems, just a couple examples. And that's it for this video. I'll see you guys in the next one.